All right, so we're talking here about composite figures. Now, composite figures is nothing more. Composite means it's more than one figure. So you have multiple items going on here. For this first one, we have to find the volume. So as you can see, this picture is broken up into two different shapes. We have a cone on the top, and then in the bottom we have a cylinder. So we have to find the volume of each one of these separately and then add them together. So that's exactly what we're going to do. So let's erase. All right, so let's get to work here. Let's first look at the cone. So the volume of a cone we know is pi r squared h divided by 3. So what we want to do is we're going to plug in what we know. This would be 3.14. Ew, 31.4. No. Let me go back. Let's try that one more time. 3.14 times the radius. So the radius don't know up here, but if we look down, this is the radius, which is 5. Square it, we get 25 times the height of just the cone part. So we're just looking at the cone part, which is 12. Divide that by 3. So that will become, using our crutch, we would get 942 divided by 3, which comes out to 314. So we have the cone part, 314 inches cubed. Now, let's figure out the bottom part, which is the cylinder. For the cylinder. So this one is pi r squared h. So we're going to plug in 3.14. The radius squared is 25 times the height of the cylinder, which is going to be 18. And we just simply take our calculator and multiply all three numbers, and we will get 1413. So now we want to combine those. 1413 plus 314. That's 7271 inches cubed, because it is volume, so it is cubed. So 1,727 inches cubed for the total figure. Again, this is for the entire thing. All right, surface area is going to be a little bit different, but it's the same principle. We want to do them separately. So let's first just look at the cone. Now let's think here. The cone we know is made up of two parts. We have like the top part, and then you have the circular base. Now in this instance, the circular base is not exposed. So therefore, we only have to find the surface area of this green part. So, knowing our formula for the surface area of a cone, we just have to use the pi r L. So we're going to do pi times the radius times the slant height. So in this case, it would be 3.14 times 5 times the slant height, which is 13. So that means the surface area, if you multiply those three together, you get 204.1. Again, you can use your crutch. So we're done with just the cone part. You do not need the pi r squared with this, because that circular, that red circle part, is not being shown. Now, as far as the cylinder goes, let me write cylinder. Okay. We want to first, once again, talk about what's being shown. The bottom base is being shown, but not the top circle. So we need the area of this bottom base, which is going to be pi r squared, plus the kind of what's the label of, if this were a soup can, the label. So that's 2 pi r h. So that would be 3.14 times the radius squared. The radius is 5. So we do 5 times 5 to get 25. Then we'll do 2 times 3.14 times the radius, which is 5, times the height of just the cylinder portion, which is 18. Now, order of operations. We want to first multiply this, bring it down. Multiply this, bring it down, then add them together. So pi times 25 is 78.5 plus 2 times pi times 5 times 18 is 565.2. Now we will just simply add those two items together. So you line up your decimals and you will get 643.7. So we have the area of both the top and the bottom. So the blue represents the cylinder, the green represents the cone, and what we want to do with these two items now is we want to add them together. So 204.1 plus 643.7. Add those up, we get an 8, a 7, a 4, and an 8. So 847.8 inches, and its surface area, so it's squared. 847.8. If you got questions, let me know. Well, see you later. Bye.